In our last class, I mentioned to you that most of the time the true, false, true, false, true, false alternates. But there's times when it doesn't. And so I wanted to show you a special case. And you'll see that this starts as special case. That's because more times than not, it's not tested on the exam. However, for those of you taking calculus, you may run into this. So I wanted to bring it to your attention. What you notice about our special case is that it's already factored. So that's great. Step 1's already done. So step 2 is to find the zeros of the numerator and denominator. So I went ahead and started that step. You'll say, well, what did you do with a square? Well, if x plus 4 is 0, then that means, of course, x plus 4, that whole quantity squared, would be 0 only when x plus 4 is 0. So all you have to do is worry about the inside part. So I would get x equals negative 4 here, and x equals negative 6 here, and x equals 3 here. Now, if it comes from the denominator, it uses parentheses. If it comes from the numerator, it depends upon the symbol. So this symbol here uses a bracket because it's got the little bar under it. Okay, put these on the number line, dividing the number line into intervals, and name the intervals. So negative 6 would come first on the number line. And negative 4 would come next. And then you'd have your 3. Negative 6 takes parentheses. Negative 4 takes a bracket. 3 takes parentheses. And that's what it would look like. Now again, I'm running through it kind of quickly since it's not one that I'll test you on. If you took the negative 7, there's a negative 7 there. We could choose a negative 5 here. We could choose 0 here, and we could choose 4 here. And we're plugging it into the end of step 1. Let's try that again. The end of step 1. So we're plugging all of these values into x plus 4 squared over x plus 6, x minus 3. Okay, if you plug in negative 7, I'll let you do the work behind that, but if you plug in negative 7, what you get is false. If you plug in negative 5 into that red part, what you get is true. If you plug in 0 into the red statement, what you get is true. And if you plug in 4 into the red statement, what you get is false. So you say, I thought you said they alternated. They do alternate most of the time, but there's one little situation in which they don't alternate. So if you look back at my problem, you'll see that negative 4 was special. It didn't alternate over the number negative 4. It said true, true there. It didn't alternate any. And the reason for it is that negative 4 has multiplicity 2. Remember that back from previous sections? See this square right here? It has multiplicity 2. That answer would have occurred twice in an equation. So since it has multiplicity 2, it did not alternate over that particular number. Remember to write your answers. You're always picking your true regions. So you could say it goes from negative 6 to negative 4, union negative 4 to 3. Okay, that's a good answer. But you'll say, well, that's just that whole interval. You could have also written it as negative 6 to 3. That would have also been correct. So talking about alternating true and false one more time, if a 0 has multiplicity that's even, it will not alternate. If you don't have any squared factors in there, it is going to alternate. So that's what you're looking for there. Do any of the factors have an exponent? If they don't, it will alternate every time.